Determine the position vector of a point R that divides the line segment joining the point P and Q in the ratio 2:1, first internally and then externally. Okay, let us begin. Let's try to understand the problem graphically first. So here we'll consider 2 points, point P and point Q. P has got the coordinates 1, 2, 1, and Q has got the coordinates -1, 1, 1. Now we're going to join P and Q with the help of a straight line. First, what we'll do, we'll consider a point. Let's call it the point R. The R is going to be lying on the line joining P and Q, and it's chosen in a particular manner. It's chosen such that it divides PQ in the ratio 2:1. Our goal will be to find out the position vector of this point R. Now to find out the position vector of point R, what we need is a point O. O is going to be the origin of the coordinate system. With respect to this origin O, we will join OP, OQ and OR, and that's going to give us the position vector of these 3 points. Let us start with the first part. So here, point R divides PQ in the ratio 2:1 internally. So using the internal section formula, the position vector of point R, which is defined by OR vector, this is going to be equals to, so we'll take 2 times the position vector point Q, that means OQ vector, added to 1 times the position vector point P, so we have OP vector, divided by 2 plus 1. This is going to be equals to 2 times OQ vector. Now our goal will be to define the position vector of point Q. However, we only have the coordinates of point Q, but this is a very simple task. To convert it to the position vector, all we have to do is take the x coordinate of point Q, which is -1, and multiply it with I cap. So we have -1 times I cap, that gives us negative I cap. Then we take the y coordinate of point Q, so that's 1. 1 will get multiplied with the unit vector j cap, so we'll add j cap to it. And similarly, we take the z component and multiply with k cap to get k cap and add it to them. Add it to the sum of negative I cap and j cap. So this is going to be the position vector point Q. This gets added to 1 times OP vector. So OP vector in terms of its position vector is going to be I cap plus 2j cap plus k cap, whole divided by, so here we have 2 plus 1. So this is going to be equals to, so let's combine the like terms in the numerator. We have -2 I cap added to positive I cap, so that gives us negative I cap. Then we have 2j cap added to positive 2j cap, so that will be 4j cap. And then we have 2 times k cap added to k cap, so that's going to be 3k cap, whole divided by 3. So this is going to be the position vector of the point R, which divides PQ into ratio 2:1 internally. Now we will go to the external section formula. Now here what we have the segment joining point P and point Q. We are extending that segment beyond Q such that it meets at the point R. Now here R is going to divide the segment joining P and Q externally in the ratio 2:1. Fine. So using this, we need to find out the position vector of point R. Now here, since point R divides PQ externally in the ratio 2:1, that means using the internal section formula, we can define the position vector of point R as, so here we will take this value 2 and multiply it with the position vector of point Q. We have 2 times OQ vector. Now this time we're going to subtract from it 1 multiplied to the position vector of point P. So that's OP vector, divided by 2 minus 1. So this is going to be equals to 2 times OQ vector. So that's negative I cap plus j cap plus k cap minus, we have OP vector. So that's I cap plus 2j cap plus k cap, whole divided by 2 minus 1. So that's going to be simply 1. Let's further simplify. We have -2 I cap plus 2j cap plus 2k cap minus I cap minus 2j cap minus k cap. So -2 I cap, negative I cap, that's going to be -3 I cap. Then we have 2j cap minus 2j cap, so that cancels out and we are left with positive k cap. Okay. So this is going to be the position vector of point R such that this particular point R divides PQ into ratio 2:1 externally.